Hi dear students, welcome you all to the Brilliant Group of Institution. Today we are going to discuss the most important previous year questions from the chapter D and F block elements for your upcoming term 2 examination. Question number 1. What is mean by lanthanide contraction? And definitely they will ask you a question from your F block elements part. What is lanthanide contraction and its consequences? What is the definition for lanthanide contraction, dear all? You know that lanthanides belongs to 4F series, right? Lanthanides belongs to 4F series, whereas actinoids are in 5F series. So in lanthanoids, why lanthanide contraction? What is lanthanide contraction? It's a steady but slow. Normally, when you move across a period, there is an increase in atomic number and there is a decrease in size, right? But the same thing is happening in lanthanides also, but the size decrease is not very fast. It's a very gradual, a very small decrease, steady but slow decrease in size. So that is the definition of lanthanide contraction. So lanthanide contraction we can define as it is the steady but slow decrease in the size of which one? Lanthanides across lanthanide series, means across the period. Okay, so steady but slow decrease in the size of lanthanide across its period with increase in atomic number is known as what? Lanthanide contraction. What is the reason? Another question for exam. What is the reason for lanthanide contraction? The main reason is what? The 4F series elements, right? 4F series, the electrons having very poor shielding or screening effect. The main reason for lanthanide contraction is which one? The 4F orbital. 4F orbital having very less or poor shielding or screening effect. So that is the main reason for lanthanide contraction. And they will ask you, there are 3 consequences we studied for lanthanide contraction, right? What are the 3 consequences for expecting question for your examination? What is the first one? The 4D and 5D series having almost a similar size. That is the first, the consequence of lanthanide contraction you may study, right? The 4D and 5D series elements having almost a similar atomic size. Then, second, the consequence you may study, the separation of lanthanide from its mixture is very difficult. If you have a beaker and I am giving you some of the lanthanide elements, some lanthanide elements I'm giving you different lanthanide elements. So you cannot separate them easily because almost their sizes are similar, like that. Due to lanthanide contraction, their size is very small decrease in size. So their almost the size is similar. So if their size is similar, most of their properties also will be similar, dear student. So from a mixture, lanthanide separation is very difficult because their size is almost similar. So properties make similarity. So for, similar properties from which you can separation of individual element is very difficult. Okay. Third one. What is the third consequence of this one? You can explain the basic character, right? You know lanthanum starting one and lutetium the ending one, right? Lanthanum hydroxide is the formula LaOH thrice and lutetium hydroxide is LuOH thrice, right? Which is more basic in nature, that you can explain through this concept. See dear student, lanthanum to lutetium there is a decrease in size, right? So lanthanum is, we can say that it is little bigger in size compared to which one? Lutetium, right? Lutetium is smaller in size. All right. So which bond you're feeling it's very stronger bond? Lanthanum is a bigger element and lutetium is a smaller element. So where is the bonding stronger, dear all, between lutetium OH or lanthanum OH? Here, right? If the smaller the cation, stronger the bonding. So here is the stronger bond. All right. This is a stronger bond is there. So stronger bond, here we can say weak bond, right? Stronger bond and here we have weak bond. Here stronger bond and weaker bond. So where you can leave OH minus ion faster? I think here. Because the bond is weaker, you can remove this OH ion faster. That is called basic character, right? Base is a substance which can give OH minus ion. So here it can donate OH minus ion. So it is basic in nature. Correct or not? OH minus ion can be donated. So it is basic in nature. So LaOH thrice is more basic than LuOH thrice. So all these three consequences. So lanthanide contraction, you should focus. What is the definition for lanthanide contraction? What is the reason for lanthanide contraction? And what are the consequences of lanthanide contraction? Most expecting question from the F block part. Okay. Next question. Why do transition elements shows variable oxidation state? Mostly they will ask you for your upcoming term 2 examination, the reasoning question from D block element. Why do transition elements form or show variable oxidation state? If they ask this question, directly write the general electronic configuration of D block element. What is the general electronic configuration of D block element? N-1 D 1 to 10 and Ns 1 to 2, right? This is the general electronic configuration of which one? D block element. Why we wrote this? Dear all, this N-1 D orbital and Ns orbital having almost similar energy. They are having comparable energy. The N-1 D orbital and Ns orbital having almost similar energy. They are just, we will call it as what? Degenerate orbital. Those orbitals having almost similar energy we will call degenerate orbital. If N-1 D orbital and Ns orbital having suppose comparable energy or almost similar energy, how it is affecting the oxidation state? Dear student, if these orbitals having same energy, those electrons can involved in bonding. Those electrons can involved in bonding. Okay, so if N-1 D, so the answer we can say that for this question, the question is what? Why transition elements shows varieties of oxidation state, variable oxidation state? The main reason, in D block element, the N-1 D orbital and Ns orbital having comparable energy or similar energy. So both or all those electrons, means N-1 D orbital and Ns orbital electrons can take part in bonding. So they can show variable oxidation state. You studied that maximum oxidation state is possessed by osmium and ruthenium around +8. Manganese shows +7. Right? So highest oxidation state is, it's a main characteristics of which one? Or variable oxidation state is a main characteristics of which one? D block element. This is the reason. Okay, their comparable energy. Next one. Write the formula of an oxoanion. Oxoanion means the compound with oxygen, anion negative charge, of manganese, in which it shows the oxidation state equal to its group number. Dear student, the answer is MnO4. This is a manganese oxide, right? With a minus anion. This is the oxoanion of manganese, MnO4 minus. You know, this getting from KMnO4, right? You know, KMnO4, potassium permanganate, KMnO4, we have K plus and MnO4 minus. You can check it. What is the oxidation state of manganese here? Manganese oxidation state, let me take it X. You know, one oxygen charge is -2, so 4 oxygen charge is -8. Overall, the charge of the complex or the anion is -1, so X is equal to, yes, +7. You know, manganese mostly exhibit the +7 oxidation state. So write the formula of an oxoanion of manganese. This is the answer, dear student, which shows the oxidation state equal to its group number. Yeah, manganese is in the group 7. So MnO4 minus is the answer. Okay, just note it. Next, explain the following observation. Generally, there is an increase in density of elements from titanium to copper in the first series of transition element. Dear student, total we have 4 series of transition element: 3D, 4D, 5D and 6D series, correct? So 3D series elements, you know the familiar 3D series are which one? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These are the 3D series element because their outermost electron enter into 3D orbital. Alright. Generally, there is an increase in density. The question is related to density, dear all. Okay, density of an element from titanium to copper. Where is titanium here? Where is copper here? Alright. They're saying from titanium to copper, while you're moving, there is a increase in density. What is the reason? Very simple question. Dear student, when you move from left to right, means across a period, There's a successive, there is an addition of electrons, right? So mass of that, see, titanium to copper, the atomic number is increasing, which means new electrons we are adding. So mass of the species increases. You know, mass is directly proportional to density. So mass increases mean density also increases. A simple reason. So titanium to copper, why density increases mean the mass is increasing because there is a successive addition of each one electrons in each element. Next one. Transition elements and their compounds are generally found to be good catalyst. Very important, dear student, good catalyst in chemical reaction. You know, normally during hydrogenation process, what is meant by hydrogenation? Addition of hydrogen. For example, let me take it ethene, a unsaturated compound to which if you are adding hydrogen, normally we are using the catalyst which one? Nickel or platinum or palladium catalyst we are using. What happened? Hydrogen added into each carbon, we will get CH3 single bond CH3 ethane. The question is very clear, why they are used as good catalyst. See, here the catalyst is nickel, platinum, palladium. All are D block element, correct? Okay, transition element. And what about one more example? You may study the preparation of sulfuric acid. Industrial preparation of sulfuric acid is known as which one? Contact process, right? Contact process. In contact process, we are using the catalyst V2O5, vanadium pentoxide. You know vanadium. Vanadium is a transition element. So why transition elements used as a good catalyst? Okay, so first reason, dear all of you, please note it, they can show variable oxidation state. Why they used as good catalyst mean? They can show, one reason, they can show variable oxidation state. We already discussed why they shows variable oxidation state in the previous question. One more reason, they can form the intermediate faster. They can form, actually this is the same reason, because of the variable oxidation state. Because of the variable oxidation state, it can form intermediate faster. It can form intermediate faster by lowering activation energy EA. Dear student, what is the major purpose of a catalyst? This is the major purpose you have studied already. Let me take it, this is your reactant and this is the product. Okay, here is the energy. Reactant is there, product is there. You please don't think that a reactant can directly convert it into product. No. In between the reactant and product, there is another state or stage. What is that? It's a high energetic state. This high energetic state is known as activated complex, or it is also known as the intermediate state. Okay, intermediate state. So when the reactant, if you mix all the reactants together, the reactant first it converted or reached to the intermediate state, then only it will give the products. If the intermediate, the energy difference between the intermediate state and the reactant is known as the activation energy. Okay, so if the activation energy greater mean, it will take a long time, right? More time to complete the reaction because the reactant need to first reach into the intermediate, then only it can give the product. So the activation energy greater mean reaction takes place with more time. In order to complete the reaction, more time is required. Then we can use a catalyst. If you use a catalyst in this reaction, the path is like this. It will follow another path where the activation energy is very lesser. So the main purpose of a catalyst is to reduce the activation energy and speed up the reaction. So dear all, why transition elements they are used as good catalyst? Remember these two examples, and the main reason because they can show variable oxidation state. For that, it will form the intermediate stage so faster by lowering the activation energy. It can speed up the reaction. Okay, next question. Explain the following observation. Question: transition elements generally form colored compounds. So most of the transition elements, their ions are colored in nature. You know the main reason is called what? DD transition. Correct. DD transition. DD transition. What is mean by DD transition? DD transition, dear student, most of the D block element or the transition elements having which one? Unpaired electron. In order to show color, all transition elements, we can, the zinc, cadmium, mercury, they are in D block element, but they are not considered as transition element. You know the reason. So in order to show color, the element should contain, which one? The element or the ion should contain unpaired electron. At least one unpaired electron is required for, in order to show exhibit color. So here the question, transition element generally form colored ion, that is due to DD transition, they having unpaired electron in their d orbital. Dear student, transition elements having a unpaired electron in the d orbital. This d orbital contain electron, unpaired electron, when it absorb energy from the visible region. When they absorb energy from the visible region, they can excited into higher d orbital, higher energy d orbital. This d orbital, the dd transition is happening. So d, the electron which is present in the lower d orbital absorb energy and they get excited into higher energy d orbital. This is called what? dd transition. And you know, the excited state, the stability of electron is very less, so they will definitely come back to the ground state by releasing the energy. So their complementary colors, we can observe it. So the main reason for the color of transition element is because of what? DD transition, because of the excitation of electron by absorbing energy from visible region. And one most important condition in order to exhibit color, the presence of unpaired electron. Okay, next one. Zinc is not regarded as a transition element. What is actually the definition of a transition element? Transition elements means the element which should contain, the element must contain a incompletely filled d orbital. The transition elements mean they should contain incompletely filled d orbital. Incompletely filled d orbital either in their metal state or its ionic state. For example, you consider zinc. So the question is related to zinc, right? So zinc element, when you consider, atomic number 30, its outermost configuration is which one? 4s2 3d8 3d10, right? This is the electronic configuration, last two orbital for the zinc. So here you can observe that d orbital is completely filled, correct? D orbitals are completely filled. So in their metal state, d orbital is fully filled. What is the condition to act as any transition element? They must contain incompletely filled d orbital. Here it having completely filled d orbital, it's not a transition. We can't fix it. Check its ion also. What is the normal ionic form of zinc? Zn2 plus, right? Zn2 plus. Zn2 plus. In Zn2 plus state, it loses the outermost 2 electron because the outermost orbital is 4s, remaining is 3d10. Still, d orbital is fully filled. Correct? So, if the element in their metal state or ionic state, if they having completely filled d orbital, they are not considered as a transition element. In order to exhibit or to act as a transition element, the element must contain incompletely filled d orbital either in their metal state or ionic state. Some more example you have already studied: zinc, cadmium, mercury. All these elements belongs to the same group and they are all not considered as a transition element. They are not transition element because their outermost d orbital is fully filled in their metal state and ionic state. Next one. Assign reason for the following. Copper 1 in the sense Cu plus 1 ion is not known in aqueous solution. The same question you can expect in another way. Copper plus 1 is unstable and copper 2 plus is stable in aqueous solution. Why? Dear student, copper plus 1 is unstable whereas copper plus 2 is stable in aqueous solution. Okay, in aqueous solution. The main reason, dear student, if a substance is stable, in the sense, especially copper related questions, if they ask, you have to connect with their E0 value, standard electrode potential. Copper plus 1 unstable and copper 2 plus is stable in aqueous solution means if a substance is soluble, all of you please note this one. If a substance is stable in aqueous solution means, okay, if a substance is stable in aqueous solution means they having very high negative value for hydration enthalpy. Hydration enthalpy. Please note it, all of you. If this, they are giving that this oxidation state is highly stable in aqueous solution. In aqueous solution means, which means they're having high negative value for hydration enthalpy. This is the point. Those who have high hydration, negative hydration enthalpy value, their oxidation state is highly soluble in the aqueous solution. So we can say copper 2 plus having high negative value for hydration enthalpy compared to copper plus 1. Therefore, copper 2 plus is stable in aqueous solution, copper plus 1 is unstable in aqueous solution. Actinoids. We are studying about lanthanoids and actinoids. Actinoids exhibit greater range of oxidation state than lanthanoids. We may study the general electronic configuration for lanthanoids. Dear student, you know lanthanide series, right? Lanthanoids, we can write the formula, and even for actinoids also. For lanthanoids, we are normally using a general electronic configuration in terms of noble gas, which one? Xenon, right? Xenon, atomic number 54. After that, we have the 4f, 5d and 6s orbital. Whereas in actinoid, we have radon, right? Radon 86. After that, we have 5f, 6d, 7s orbital. So this is the general electronic configuration we are using to explain to write the electronic configuration of which one? Lanthanoids and actinoid. You know, lanthanoids, the orbitals are outermost orbitals are 4f, 5d, 6s, and actinide 5f, 6d, 7s. Question: actinoid exhibit greater range of oxidation state. Why? We studied why transition element D block, why transition element shows variable oxidation state. What is the reason we studied? Do you remember? The n-1 d orbital and ns orbital having almost a similar energy, those electrons can take part in bonding. The same thing here. In actinoid, 5f, 6d, 7s, these orbitals having almost similar energy. In actinoid, the outermost 5f, 6d, 7s orbital having almost similar energy, those electrons can take part in bonding. Therefore, it shows variable oxidation state. Lanthanoids can exhibit +2, +3, those kind of oxidation state, because there is a little larger difference in the energy between the outermost orbitals. So actinoid, let me conclude why actinoid shows variable oxidation state compared to lanthanoid means actinoids, the outermost, which are orbital 5f, then 6d and 7s, these orbitals having almost a similar energy, those electrons can take part in bonding, so they will show varieties of oxidation state. Then assign reason for the following. Manganese exhibit the highest oxidation state of +7 among the 3D series of transition element. We know that 3D series elements we already discussed, in which manganese is the central atom. The central atom manganese. Manganese atomic number, you know, 25. Its configuration we can write it as 4s2 3d5. All right. Manganese mainly exhibit which oxidation state? They said +7. Manganese +7. How manganese can acquire +7 charge? By losing 7 electron, right? So 2 electron from 4s, 5 electron from 3d. So what is the remaining one? Remaining is argon configuration, means atomic number 18. Okay, you know, up to 4s2 mean 20 electron. So if 20 electron, which 2 electron gone, the remaining element is which one? Argon, that is 18 electron. You know, it's a argon is a noble gas. It's a stable configuration. So why manganese exhibit +7 oxidation state? In order to attain or to get a stable electronic configuration for a noble gas. Okay, simple one. How would you account for the following? Chromium 2 plus is a reducing in nature. They said chromium 2 plus is reducing in nature. Reducing in the nature means they are reducing agent. Chromium 2 plus is a reducing agent, while with the same d orbital configuration D4, Mn3 plus is an oxidizing agent. You know, Mn3 plus they are saying it is an oxidizing agent. Oxidizing agent. Okay, dear student, let us study. Chromium, you know what is the normal state of chromium? Chromium atomic number 24, we can write the configuration is 4s2 3d4. You can make it half-filled stabilization. Here we are dealing with oxidation state. Anyway, we are going to remove the electron, no need of that. What about chromium 2 plus? Chromium 2 plus mean it has to lose the outermost 2 electrons, so the remaining is 3d4. Yeah, it having a d4 configuration. What about manganese? You know, manganese atomic number is 25, so the configuration is which one? 4s2 3d5. What about Mn3 plus? Okay, they given Mn3 plus. Mn3 plus mean they have to lose 3 electron. 2 electron from 4s, 1 electron from 3d, remaining is 3d4. Yes, both of Cr2 plus and Mn3 plus having same configuration d4, d4. Correct one. And the question, why chromium 2 plus act as a reducing agent? Dear student, what is a reducing agent? Reducing agent means they can undergo oxidation. They can undergo oxidation. What is mean by oxidation? Loss of electron. Correct or not? Reducing agent means it can undergo oxidation. Oxidation means what? Lose of electron. You just check it. Chromium 2 plus can lose electron or not? Just check it, all of you. Chromium 2 plus. Chromium 2 plus, when it lose 1 electron, it converted to chromium 3 plus, right? Chromium 2 plus, when lose 1 electron, it become chromium 3 plus. Check it, all of you. Chromium 3 plus is stable or not? Then only it can lose 1 electron, right? Chromium 2 plus electronic configuration we already discussed. It's having D4 configuration. When it lose 1 electron from D4, it become D3. Dear student, D3 configuration is stable in aqueous solution. D3 configuration is stable in aqueous solution. Why? D3. What is the meaning of D3? D orbital having 3 electron. Correct? D orbital having 3 electron. You know, when it is splitted, we studied in coordination complexes, it will give you 2 level T2G and EG level, right? T2G means the first 3 orbital, it having 3 electrons. See all of you, T2G orbital is half filled. So T2G3 is the configuration. T2G3 is stable configuration because of half filled stabilization. So D3 configuration is stable in aqueous solution. So chromium 2 plus is ready to lose 1 electron. So it can act as a reducing agent. Come to manganese. In manganese, dear all, manganese act as an oxidizing agent. What is an oxidizing agent? Oxidizing agent means it will undergo reduction. What is mean by reduction? Reduction means gain of electron. Reduction means what? Gain of electron. Dear all, let's go. Manganese 3 plus is the species they given right initially. Manganese 3 plus, what is the configuration? D4. Manganese 3 plus mean D4. When it gain 1 electron, because gaining 1 electron, it becomes what? D4 converted to D5. D5 configuration is stable or not? Yes, right. D5 configuration means the D orbital is half filled, right? D orbital is half filled, it is stable. So make a back calculation like, what is the reducing agent? It can undergo oxidation. What is oxidation? Losing electrons. So check it, the species, if it lose electron, stable or not. D3 configuration is stable in aqueous solution due to the T2G3 half filled stabilization. Whereas manganese is stable with the D5 configuration, it's half filled stabilization. Okay. Question number 2. In a transition series of metal, the metal which exhibit greater number of oxidation state occur in their middle of the series. Simple one. For example, let us consider 3D series. Our elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You know, scandium atomic number is 21, right? 21, 22, 23, like that. So the configuration you will get it here. 4s2, 3d1, 4s2, 3d2. So the electrons are added into which one? D orbital. D4, 3d5. 3d6, 3d7, 3d8, 3d9 and 3d10 is the configuration. Easy we can able to understand. D1. D1 means, dear student, the D orbital having just 1 electron. If it is D2, one more, 2, 3, 4, 5 up to manganese, unpaired electron increases. What about iron? Iron 3d6, 3d. So 3d5 means D orbital having 5 electron like this, 5 unpaired electron. What about 3d6? 3d6 means we can fill the electron like this one, 1, 2, 3, 4, 5, 6. See, unpaired electron decreases, right? So up to the middle, Greatest oxidation state is possessed by manganese. We discussed now +7. The greatest oxidation state is possessed by the middle element +7, because up to that element the unpaired electrons are increasing. But after that electrons undergo pairing, so oxidation state gradually decreases. So the main reason is from left to the middle elements, the unpaired electrons numbers are increasing, so their oxidation state increases. After the middle section, what happened? The electron starts to pairing, so unpaired electron decreases, oxidation state decreases. Then explain giving reason transition metals and their compounds generally exhibit paramagnetic behavior. Simple question, you know, dear student, in order to show paramagnetic character, they should contain unpaired electrons. Yes or no? They should contain unpaired electron. We already just observed transition elements should have unpaired electron. What is a transition element? Transition elements mean the element in their metal state or the elemental state or in the ionic state, they must contain incompletely filled d orbital. So they having unpaired electron. If they having more unpaired electron, more paramagnetic, less unpaired electron, less paramagnetic. So anyway, transition elements mostly they are paramagnetic in nature because of the presence of unpaired electron. The chemistry of actinoid is not so smooth as that of lanthanoids. So lanthanide general configuration we studied, you know, xenon, 4f, 5d and 6s. And what about actinoid? Actinoid we are using radon and the orbitals are 5f, 6d and 7s orbital. We have already discussed that the chemistry of actinoid is not so much smooth as that of lanthanoid. The study of chemistry of actinoids are little difficult. Why? You know, I told you that the 5f, 6d and 7s orbital having almost a similar energy. So all those electron can take part in bonding. Therefore, they shows variable oxidation state. Lanthanoid shows a limited oxidation state, whereas actinoid can show variable oxidation state. So their study of if they exist in different oxidation state, the study of chemistry will be difficult. Okay, that's the main reason. Then explain the following. The enthalpy of atomization of transition metals are quite high. What is meant by enthalpy of atomization? Dear all, if you consider a metal connected with another metal, you know, metal bond is called metallic bonding. If you want to break this bond, you have to give some amount of energy and you can convert it into their atoms, right? This is called what? The enthalpy of atomization. The energy, enthalpy means, you know, the heat energy. The heat energy required to break a bond to convert into their atom is known as what? Enthalpy of atomization. Enthalpy of atomization greater means you have to give more amount of energy to break the bond, which means the bond is stronger. Correct? If the bond is stronger, high enthalpy of atomization is required. The enthalpy of atomization of transition metals are quite high. Dear student, transition elements we just discussed now, transition elements having number of unpaired electrons. They having many number of unpaired electrons. If there are many number of unpaired electrons, they can take part in bonding and the metallic bonding will be stronger. Stronger the metallic bond. Dear all of you, when a metallic bond strength increases, if there are more electrons take part in bonding, the metallic bond strength increases. In transition element, they having many unpaired electrons. So this unpaired electron when take part in bonding, the metallic bond strength increases. So metallic bond strength increases mean if you want to break it, more amount of energy you have to apply. Therefore, we can say that it's having high enthalpy of atomization. High enthalpy of atomization. Hope you clear the answer. Second question, the transition element metals and many of their compounds act as good catalysts. That's already we discussed, right? Why they used as catalyst, dear all? First reason, transition element shows variable oxidation state. Second reason, and because of this variable oxidation state, what they're doing? They're forming the intermediate state so faster by lowering the activation energy. Correct. We discussed before. Now, Which metal in the first transition series, that is our 3D series, exhibit +1 oxidation state most frequently? Dear student, the elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and copper, zinc. These are the 3D series element in which element exhibit +1. We studied manganese shows +7 oxidation state, and scandium mostly shows +3 oxidation state because its outermost 3 electron, when it lose, it will get stable noble gas configuration. And remember, the +1 oxidation state is exhibited mostly by copper because, dear all, copper atomic number is what? 29. We can write the configuration as 4s2 3d9. What is mean by copper +1? Suppose copper existing in +1 state, what will happen? And you know, within the ground state itself, there is a small change in electronic configuration, right? From 4s orbital, 1 electron goes to 3d. You will get 4s1 3d10. Why they are transferring electron? To attain stable half-filled and fully filled stabilization, right? This is copper ground state. What about copper in +1 state? It has to lose 1 electron. It loses 1 electron from 4s because that is outermost electron. What is remaining? 3d10. Correct. So why copper exhibit +1 oxidation state? Because in +1 state it having a fully filled d orbital configuration. Therefore it is highly stable. Which of the following cations are colored in aqueous solution? Dear student, we discussed already before why a transition elements shows color. Color is mainly because of DD transition, right? But in order to show color, I already mentioned that in order to show color, the element or the ion should contain unpaired electron. If they having unpaired electron, then only DD transition. These unpaired electrons undergoing DD transition. So if they having unpaired electron, they are colored. If not having unpaired electron, colorless. Let's see. Scandium 3+ is the question. What about scandium? Scandium atomic number 21. Configuration is 4s2 3d1. Scandium 3+ is the question, right? Scandium 3+ mean it has to lose outermost 3 electron. So it will get a argon configuration, 18 electron. Is it having any unpaired electron? No. So it cannot show color. So scandium 3+ cannot show color because it not having unpaired electron. Second question is given as vanadium 3+. Dear student, vanadium atomic number is 23. Its configuration is 4s2 3d3. Vanadium, the configuration is vanadium 3+. Vanadium 3+ mean it has to lose 3 electron, 2 electron from 4s, 1 electron from 3d, remaining is 3d2. 3d2 means, you know, the d orbital having 2 electron. Yes, unpaired electrons are there. It can show color. So vanadium 3+ can show color. Next one is given titanium 4+. Titanium, scandium, titanium. Titanium atomic number 22. Configuration is 4s2 3d2. Titanium 4+. Titanium 4+ mean it has to lose outermost 4 electron. It will get argon noble gas configuration. Dear student, how fully filled, right? Argon fully filled. Our outermost orbital is fully filled. It not having unpaired electrons. So titanium 4+ cannot show color. Let's go to the last topic. Which one? Manganese Mn. Manganese atomic number 25. So the configuration is 4s2 3d5. Here they given Mn2+. Mn2+ mean lose outermost 2 electron. Remaining is 3d5. 3d5 means the d orbital having total 5 unpaired electron. See dear all, unpaired electron, if it is there, it can show color. So which of the following cations are colored? Means you can say vanadium 3+ and Mn2+ are colored. Scandium and titanium are colorless. Next one, the transition metal with the exception of, you know, zinc, cadmium and mercury. Why they not considered as transition element, right? Because they are having fully filled d orbital. They are hard and have high melting and boiling point. Yes, student, transition elements generally having high melting and boiling point. What is the reason? Just already we discussed. Transition elements contain unpaired electrons. More the number of unpaired electron, more stronger will be the metallic bonding. The stronger the bond, what happened? They having high melting and boiling point, that already we discussed, due to high enthalpy of atomization. Once again, I am repeating all of you. In transition elements contain many number of unpaired electrons, right? They having a number of unpaired electrons. they having a number of unpaired electron. As the number of unpaired electron increases, their metallic bond strength increases. So stronger the metallic bond. Stronger the metallic bond. If the bond is stronger, they're having high enthalpy of atomization. High enthalpy of atomization. Just before we discuss that, enthalpy of atomization. Because of stronger bond and high enthalpy of atomization, they're having high melting and boiling point. Okay, high melting point and boiling point. So the stronger the bond, high melting and boiling point. So make a connection and study that. Easy. One last question in the part 1. The highest oxidation state of a transition metal is usually exhibited in its oxides. Oxides. And fluorides. That's also one of the question. Why higher oxidation state of, transition element shows variable oxidation state? Why their higher oxidation state is only stable with their oxides and fluorides? Dear all, metal is there. Metals are electropositive species. They are ready to lose electron. The other side you have oxide, mean oxygen will be there. If it is fluoride, fluorine will be there. Alright. So here, oxides and fluorides, in these cases, metal with oxygen, metal with the fluorine. In these cases, only metal higher oxidation state are stable. Why? Oxygen and fluorine are smaller element. They are highly electronegative element. They're ready to take electron from the metal, and metal is ready to lose electron. They make the bond very stronger. Stronger the bond, stronger the bond, they're having high lattice enthalpy, right? High lattice enthalpy. They can form metal with oxide, metal with the fluoride. They can form ionic bond, right? Metals are positive charge, oxides are negative charge. Metals are positive charge, fluorides are negative charge. So metal and oxide, metal with the fluoride, they can form very strong ionic bond because oxygen and fluorine are smaller element. They are highly electronegative element. They are ready to take electron from metal. So metal can show higher oxidation state only in their oxides and fluorides, and the formed bond is having high lattice enthalpy. Very stronger the bond, high lattice enthalpy. So highest oxidation state of a transition elements are most stable in their oxides and fluoride, especially in oxide. They can ask you another question, whether metal oxides or metal fluorides, which is highly stable? Metal oxide, yes student, because fluorine can make only single bond with the metal atom. Fluorine can make normal single bond with other element, but oxygen have an ability to make double bond. So double bond is stronger than single bond. So metal oxides are little stable than metal fluorides. Clear all of you? So this is the part 1 discussion for the chapter D and F block elements. In part 2 video, the remaining previous year important questions, we can discuss it. Okay, thank you all. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.